Hi everybody, so today we're going to be talking about isosceles and equilateral triangles. All right, so first let's talk about our isosceles triangle and their theorems. A couple things about an isosceles triangle. An isosceles triangle is a triangle with at least two congruent sides. Now, the thing you have to be careful of with an isosceles triangle is that we often, when we draw an isosceles triangle, draw it vertically straight up and the two sides being the ones on the left and the right. Those two, if they're congruent, we call them the legs. And then the side opposite, the one that isn't congruent, we call that its base. The problem is I don't actually have to draw an isosceles triangle like that. I could draw a triangle like this and make these two the congruent sides, or I could even draw it like upside down and make these two the congruent sides. So when you're given information, whether it's in a problem or in a proof, be very careful about the sides that are being congruent, and don't just assume that it's these two, the ones that are kind of straight facing you, that are the congruent sides. Remember, we don't want to ever assume in geometry. Okay, so we've actually talked about the isosceles triangle theorem and its converse already, but I'm going to actually state them for you. So the isosceles triangle theorem says that in any isosceles triangle, so we're going to do this, we're going to say A, B, and C. If I give you these two sides congruent, then the sides opposite, or the angles opposite those sides, are therefore congruent. So let's state that. In any isosceles triangle, the angles opposite the congruent sides are congruent. So for example, in this particular triangle, then angle A would be congruent to angle C because it's an isosceles triangle with legs of AB and BC. All right, now the converse of that basically says that if I give you a triangle, okay, here we go, switching to blue, A, B, I'm switching the letters around, and I tell you that angle A and angle B are congruent, well, then the sides opposite those angles are congruent. So that would make this side congruent to this side. So it's the converse of it. I'm telling you the angles are congruent, therefore the sides would be congruent as well. So if a triangle has two congruent angles, then the sides opposite those angles are congruent. So it's therefore isosceles. Okay, so those are the two theorems, and we actually have reviewed them, and let's practice. So I give you a triangle. It says DE is congruent to EF. I want to be very careful in my labeling. So DE is congruent to EF. As soon as I do that, then I'm going to mark the angles that are opposite them congruent. So I'm going to mark this congruent to this because of the isosceles triangle theorem. So now it says if the measure of angle F is 40 degrees, so this is 40, find the measure of angle D. Well, if F is 40, well then D is 40 because they are congruent. So the measure of angle D would be 40 degrees. All right. Now, I say to you that, and let me erase that, I say to you that the measure of angle E is 70 degrees. Huh. Well, I know that both F and D are equal, so if I wanted to write an equation, I could say that this is X and this is X. So then I know 2X plus 70 has to equal 180. That's if you want to write an equation. And then you subtract 70, and you get 2x equals 110. So then x, and divide by 2 on both sides, so x would be 55. So that's how you do it algebraically. Or you know that if this is 70, if angle E is 70, you do 180 minus 70 and get 110. And you know these two angles then have to be equal, so you would divide 110 by 2. It's the exact same process either way, I would accept your answer in finding angles. I really also should have added like a 3. So let's do that. Let's go add in another example 3. Okay, so example 3 would say something like this. If segment DE is equal to 2x plus 5 and EF was equal to 3x minus 10, find x. Okay, so now I'm giving you the segments. Well, just like we would, we label our diagram. So DE is 2x plus 5, and EF was 3x minus 10. Since they are congruent, I can write an equation by setting them equal to each other. Okay, and then I go through the process of my algebra and I solve for x. So I'm going to subtract 2x to both sides, and I'm going to add 10 to both sides. So I get 15 equals x. And if I wanted to, I could also find their length, but for now we're going to leave it like that. Okay? All right. Next page. Can make this a little bit harder because you have to notice that isosceles triangles come up in very different places. Okay? So in this I gave you a circle, and I want you to recall that from the center of a circle to the line, the segment that goes from the center to the circle is called a radius. Okay? And you need to know, we can recall this again. All radius or radii are congruent. Okay. So as soon as I see a circle R, I know that's the center. I'm going to go ahead and mark those two sides congruent. Then it says the measure of angle R equals 22 degrees. Then it says find the measure of angle RXZ. Well, RXZ is not part of the, I don't know how to create a circle, an angle with a circle with an arc. So I actually have to connect it. And what's happened is I've created an isosceles triangle, okay? Created this really cool isosceles triangle. All right, so it wants us to find the measure of RXZ. I'm going to put a little x there. Well, if it's an isosceles triangle, I go ahead and I mark my angles congruent to each other. And so if that's x, then that is x. So I can write an equation to solve for x. So 2x plus 22 equals 180 degrees. All right, do my algebra. I'm going to subtract 22 from both sides. And so I get 2x equals, what is that, 158? 158 and 2 is 60. Yep, 158. And then divide by 2. And so I get x is equal to, let's see, 2 into 158. 2 goes into 15 7 times. I get 14. I subtract. And I bring down the 8. So 2 goes into 18 9 times. So 79. Look, I didn't even need a calculator. I could do the work on my... So now that I know that the measure of angle RXZ is 79 degrees. Okay. Moving on. All right, so now how would I do that? How would I do a proof with something like that? Oh, where'd my proof go? Okay, well, I'll start over with the proof. We were given that PQ is congruent to QR, and we're trying to prove that the measure of angle 1 is congruent to the measure of angle 3. And I've got something like this. Sorry, my diagram is not so pretty. And we've got P, angle 1, we've got a Q, we've got angle 2, and we've got angle 3, and we've got an R. All right, so first thing I do, look that I'm trying to prove angles congruent. I see that I only have one triangle, so I know it's not proving using congruent triangles because I'd need at least 2 triangles to do that. So I mark my diagram with what I'm given, and I'm given that PQ and QR are congruent. That will tell me, I know that that tells me that then 1 is equal to 2 because of the isosceles triangle theorem. I also see that 2 and 3 are vertical angles, and if 2 and 3 are vertical angles, they're congruent. That makes 1 and 3 congruent by the transitive property. So now I've got to get that all into a proof. So I start with my given, PQ, congruent to QR. And I know that I went kind of fast on that because I think this one's pretty, kids usually see this one pretty quickly. And you've been getting so good at proofs that I'm hoping you're starting to see that. If PQ is congruent to QR, the next mark I made on my diagram was that angle 1, or measure of angle 1, was equal to the measure, and this should actually say equal, not congruent, to the measure of angle 2. And that would be because of the Isosceles Triangle theorem that we just learned. If the sides are congruent, then the angles opposite those sides are congruent. All right, then I used my vertical angles, so I said that measure of angle 2 was equal to the measure of angle 3, and that's our favorite theorem, that, the vertical angle theorem. Vertical angles are congruent. And then we've got our last one. I can connect these guys using angle 2, so measure of angle 1 equals the measure of angle 3 because of the transitive property. The transitive property. Okay, perfect. All right, the last thing I really want to review is equilateral triangles. We've spent a lot of time working on these, so this should be completely review. Equilateral triangles are triangles where all sides are equal. All 3 sides are equal. All angles are also equal. And each angle is 60 degrees. You are going to have to know that about an equilateral triangle. Okay, all angles are congruent. Each angle is 60 degrees. So I give you an equilateral triangle, and I tell you that this is x plus 5, this is 2x, and this is, I don't know, 3x. And I say 3x minus 1. I say find x. Well, you don't have to use all of the information. You could do that 2x equals x plus 5, subtract x, and then I know x equals 5, okay? And just worry about the 2 sides, okay? Ooh, actually, that one doesn't work, so I'm going to leave it like that. So if I told you it was equilateral, then you could do that, and then you'd know that this guy's 10, this guy's 10, so therefore this guy would also be 10. The lengths, the side lengths are all the same, and therefore each angle would be congruent as well. Okay, so now we've spent a lot of time already talking about equilateral triangles in class, and we're going to be practicing all that tomorrow in class, so have a great night.